This is the Philips Special Glass Factory in the Dutch town of Winschoten. This film has been made to describe the preparation and measurement of strain slab samples used for determining the expansion of production glass and thus its quality. This shot shows normal production work of tube glass drawing. To check quality, a sample is taken from production glass The glass sample, which can have various shapes, must be homogeneous and free from cords, bubbles and stones. The piece of sample glass is melted against a piece of standard glass whose precise physical qualities are known. This standard glass is supplied by Eindhoven in the form of bars or slices. A stock is formed of 13mm cubes and carefully stored. Production glass to be tested is melted to the standard glass in a small electric furnace at 30 to 70 degrees centigrade higher, dependent on the glass type. If the production glass is supplied as a thin-walled product, for which a pair of flat tweezers is used. This cube is first cooled and then sawn to size. From the face that will be contiguous to the standard glass, about 1 mm is ground off. The opposite face is used for the glass ink mark. The cubic sample of production glass is placed on a holder, numbered face down, and a piece of standard glass is placed on top of it. The holder, with one or more combinations of samples, is placed in the temperature-stabilized furnace. Then, the furnace is allowed to return to its original temperature. Every minute, the cover of the furnace is lifted and appearance of the mark at the bottom of the piece of production glass is checked. The moment the mark at the bottom of the piece of production glass shows up, the seal between the sample of production glass and standard glass is complete. The holder is transferred to a second furnace, which has been adjusted to a temperature above the annealing point of the standard glass, dependent on the glass type, of 40 degrees to 80 degrees centigrade. Until a temperature of 200 degrees centigrade has been reached. Now, the cover is removed. At a furnace temperature of about 100 degrees centigrade, the holder is taken out and the sample allowed to continue cooling in the open air. From a correctly prepared seal, a 6 to 8 mm thick sample is cut. Top and bottom faces should run parallel and be perpendicular to the sealing face. The identification number is copied on the production glass. Type and height of the stress in a seal of production and standard glass can be determined with a polarizing microscope, such as the Light's Labelux or the Light's Diavert, equipped with a lambda plate and one or more compensators. Normally, two types of compensators are used. Type K for measuring tensile stress and Type M for measuring compressive stress. In addition, a stress-free glass cuvette containing pure toluene, pro analysis, is needed. For the test, exhaustion of toluene fumes is necessary. The standard glass pointing to the analyst. Remember that the microscope, except the light's diavert, inverts the image. Left becomes right and top becomes bottom. The measuring location is determined with the diaphragm open. The dark shadow lines, more or less perpendicular to the dividing line, should be made to intersect with the line on the cuvette by moving the cuvette in the direction of the dividing line. The microscope table is now turned 45 degrees anti-clockwise. Focusing on the ceiling face. The dividing line runs from left-hand bottom to right-hand top. If there is hardly any or no stress at all, the colors on both sides of the dividing line are identical. Measurements should be made anyway. If there is stress, the colors are different, as in this picture. Blue color points to tensile stress, yellow points to compressive stress. The type of stress prevailing in the standard glass is determined. The compensator to be used for measuring the type of stress found in the standard glass is set at 0. The measuring point is obscured by turning the compensator button and partial closure of the diaphragm. This is repeated, but now with the compensator button turned clockwise. The nanometer figure found is divided by the thickness of the strain slab in centimeters. The strain value found is checked against the requirements. The procedure for making and measuring strain slabs has been laid down in 2 GLVs and this video film. Should you have any questions on this subject, don't hesitate to contact Chem Bell Glass Department in Eindhoven.